Now, many times we have calculated that for a period of 30 days, if we run this machine for 8 hours a day, we shall be able to meet the total demand. By meeting the total demand does not mean that all your orders are going to be on time. Yes, something which is required on 24th will be dispatched on 27th. But your orders are still late. Let us see what happens if we are able to run this machine in overtime. The slow machine runs in overtime. The inventory levels come down, but only one of my work orders is late. And let me now try and see if I move the transfer batch to 5 pieces, is there a chance I'll be on time? No. So there is very less sensitivity between 5 and 15. A slight increase in WIP, that's all results. So there's no use you trying to bring the transfer batch down to such a small level where the manpower required to transfer the material is much higher than the benefit you get. So we have 2 machines working on normal calendar and one working on overtime calendar, which is generally the sense. There was a machine which was capacity constrained because it had low rates of production. So you work it, instead of 8 hours, you work it 10 hours. And since you work it 10 hours, naturally a lot of your orders are going to be on time. But we still have enough capacity on the finished things because the rate of production of that is nearly double. Let's have a look at what overtime would do if we ran the finished stage of operation also in overtime. The inventories went down, all the orders on time. Though initially also finishing operation had enough capacity, that means it had double the production capacity of the assemble stage, which was my constraint. A first increase in performance happened when I was able to run this machine in overtime. That improved my performance. Now, why would anybody run an operation which is called the finish operation also in overtime when there's enough capacity available for it during its normal working time? That means if the machine keeps working on the normal calendar, it still has enough working capacity. But the moment I put it in overtime, the orders were on time. This is what I had previously mentioned when I said that you may have an installed capacity which is going to meet your total demand for the month, but even then you may have times where your orders are going to be late. So what just happened is, now I have a finished machine also which is working in overtime. That is reducing the waiting time of a work order. For example, there's one machine which is working in 2 shifts and one machine is working in 1 shift, and the 1 shift, the 2 shift is feeding the 1 shift. So, and they both have the same rate of production, or 2 shift has got lesser rate of production. So whatever, let us say the 2 shift operation produces, the 1 shift operation consumes in 1.5 days. So half a shift production is going to lie in front of the machine which is now working in 1 shift. That means the material is not flowing, it is waiting. If you run both the machines in two shifts, whatever gets produced by the previous machine gets processed immediately on the next machine and is out of the system. This is the reason why by working the finishing operations also in overtime was made all the orders go out on time. So what I did was actually went ahead and further unbalanced the capacity. When I started off, I had a full balanced capacity, but I was not able to deliver my order on time. And what I've now landed up doing is I have totally unbalanced the capacity. But in trying to unbalance the capacity, I have balanced flow. And this is again the golden rule of production scheduling. You do not balance capacity, balance flow. And it can happen sometimes that the activation and the utilization of the machine are different. And by making the finishing operation also run overtime, which already had enough capacity, what I did was I synchronized it. That is, as the material comes off the assemble work center, it does not wait. It gets immediately processed in the finish and gets sent out. That means I just increase the flow. So when I unbalance the capacity, I tried to increase the flow. Hence the orders on time and also the inventory is less. By understanding constraints, transfer batch and delivery dates, we saw that WIP is very closely related to flow. In cases where WIPs are very high on the shop floor, the chances are the flow is being hindered somewhere.